This video is going to talk about ordering decimals and figuring out which fraction is greater. So if we look over at this slide, we can see 2/10 and 7/10. And if I want to compare these fractions, they both have the same denominator, so I know that 7/10 is greater. If I see 2/10 and 7/10, I can compare by lining up the decimal point. 2/10 and 7/10, well, 7 is the bigger number and it's the first number that's different. So 7/10 is greater. We also know they're equivalent. They want to write the decimals as fractions and then to compare which decimal is greater. We can do that. So we can compare 4/10 and 3/10 and see that 4/10 is greater. We can compare 0.35 over 100 because I'm doing hot summer day, and 27 over 100 and see that 35 is bigger than 27 and both the denominators are the same. I can compare 8/10 and 9/10 and I can see that 9/10 is bigger. I can compare 76 over 100 and 84 over 100 and I can see right here that the 84 is going to be bigger because 84 hundredths is bigger than 76 hundredths. They want to figure out which one is the biggest in each pair. So we have 5/10 and 36 hundredths. Well, if we turn both of these into fractions, 5/10 is just over 10. 36 is over 100. So in order to really compare them, I can't use 5/10. I have to use 50 over 100 by adding a 0 to the top and bottom. This is the only way that the denominators are the same. And now I can see that 5/10 is actually bigger than 36 hundredths. I can also see it by lining up the decimal. 0.5, 0.36. Now I can put in invisible zeros on anything that doesn't share a place value, and that will help me see that 50 is bigger than 36. I can also just compare the first digit that's different the same way I would with whole numbers and see that 5 is bigger than 3. They want to write the decimals as fractions with the same denominator to compare which one is greater. So this would start off as 3/10 compared to 24 hundredths. You can see the way that hot summer day works there. Except 3/10 is not the same denominator as 24 hundredths. So we're going to add a 0 to the top and bottom. And now I can see that 30 hundredths is bigger than 24 hundredths. Same thing over here. I can hot summer day these, and I can make it 57 over 100 and 614 over 1,000. I need to compare the same denominator, the same size pizza slices, and this is not, so I'm going to add a 0 to both sides. And I'm going to see that even with that extra 0, 570 thousandths is not the same as 614 thousandths, which means that 614 is bigger. Let's say I want to compare 7/10 to 64/10. I could write them both as hundredths and make it interesting. Now they're doing what I was talking about before. 0.7, 0.64. When we line up the decimal point, which you can totally see there because of that little square that always pops up, when we line up the decimal point, we can see when we add in that 0, we don't need it, but it helps us to compare the numbers in there. We can see that 70 is bigger than 64. So 7/10 is bigger than 64 hundredths. Let's go ahead and do the same comparison here. Give this a shot and then we'll talk about it. Welcome back. So we have 0.4 compared to 0.51. We need a place value here, 40, 51. 51 is bigger. We have 0.5 compared to 0.47. Need a place value here, 50 is bigger than 47. So 5/10 is bigger than 47/100. 0.3, 0.28, missing a place value here. 30 is bigger than 28. 3/10 is bigger than 28/100. So we can do the same thing here. When we line up the decimal points, we can see that this is difficult to compare. You might immediately see that 5 is bigger than 4, and you might know that this one's bigger. Awesome! Maybe it helps you to have these placeholders in here so that you can really see that there is a 500 there. I encourage you to use those invisible zeros. It helps you to avoid making an easy mistake. Let's go ahead and do the same thing here. You give these a shot first, and then we'll talk about it. Line up the decimal. Welcome back. Let's go ahead and start off with 0.35 and 0.4. Well, I can see that 4 is bigger than 3. Add in the 0. Yep, definitely still true. Over here we have 0.006 and 0.03. I could put a placeholder in here. These digits are the same. That doesn't help. These digits are different. 3 is bigger than 0. This is my bigger number. 0.786, 0.31. Add that invisible 0. 7 is bigger than 3, so 786 thousandths is bigger than 31 hundredths. If you did the bonus, let's go ahead. I'm going to cheat here. I'm just going to line it up here. 0.24, and I could add the zeros here, but I can tell that that 2 is bigger than 0, so that's the bigger number. When the whole number parts are the same, you just have to compare the decimal points. The decimal parts. So if I have 0.5 compared to 0.36, I can see by putting in that invisible 0 that 50 is bigger than 0.3. That 50 is bigger than 36, or 5/10 is bigger than 36 hundredths. So over here, when I look at this one and I compare 4.5 to 4.36, it's the same thing I did over here. Now I just added a 4 in front of it. Add my invisible 0, the 4's are the same. Here's the first different number. So 4.5 is bigger than 4.36. All right, go ahead and compare these, and then we'll talk about it. Make sure you line everything up. Welcome back. So we start off with 3.4 and 3.067. I can see that 4 is bigger than 0 even before I add these in, so that's my bigger number. 8.56 compared to 17.00. Why am I even doing this? I know that 17 is bigger than 8. Psh. 2 and a whole number, 20 in a whole number. 20 is bigger. No whole numbers here, but I have 5 in the 10ths place and 3 in the 10ths place. 5 is bigger. 0.03, 0.295. Well, if I look at the first number after the decimal place, 3 is bigger. Let's test that out. 0.3, 0.295. Look at that. Still true. 300 is bigger than 295. 61 and 3/10, or 62 and 104 thousandths. 62 is bigger than 61. Over here, this number is longer, but 88 is bigger than 8. So, same thing. We have a longer number over here, but it doesn't really matter how long a number is, especially with a decimal. You have to be very careful, because this whole number is 37, and this whole number is 364. I'd rather have 364 rather than 37.9999999. So they want us to name a decimal between these two numbers, 0.4 and 0.9. Well, a number between 4 and 9 might be 5. So a number between 0.4 and 0.9 could be 0.5. Or between 4/10 and 9/10 could be 5/10. What about something between 4.3 and 4.4? Well, what's between 4 and 3/10 and 4 and 4/10? I have 4.3 and 4.4. Well, there's no real number between 3 and 4, so let's use invisible zeros, and let's see if this makes a difference. Can I find a number in between here? Sure. 4.35. And now I've found a way to get a number between there. Are there any number? Yeah, we just did that. So they want you to find a decimal between the numbers. Your decimal may not match my decimal. All right, let's talk about it real quick. I'm just going to do the first two. 7.8 and 7.9. I need something in between there. There's no number between 7 and 8, or between 8 and 9. So I'm going to add a 0 on here. And I might say 7.81. I might say 7.89. I might say 7.88. Anything in between there will work. Letter B, 0.25 and 0.26. Well, I'm going to have to add the zeros in here. So a number in between there, because I definitely left room for that, is 0.256. Why not? In between 0.2 and 0.24, if I add the 0 in here, that makes it easier for me to compare. I might have gotten 0.23. So, to compare things, you just want to compare the first number that's different. This is the same, so this is the number that's different. This is the same, so this is the number that's different. Having the decimal point there doesn't really make a difference. You can line up the place values by lining up the decimal points, because the decimal point is always between the 1 and the tenths. So they want you to find the largest place value. Which of these decimals is the biggest thing here? Let's split these like this. So in here, the largest one, these are the same, these are the same. The difference between 0 and 1, 1 is bigger. Same, same, same. Ooh, not same. 9 is bigger than 8. This one's bigger. This trick only works when you line up the decimal point, because the decimal point is always between the 1 and the tenths. 1 to nothing. 13 is bigger than 3. Done. So they want you to order these fractions from least to greatest by lining up the decimal points. So let's go ahead and put these vertically instead of horizontally. Letter A would be 0.6, 0.78, 0.254. So that means when we add in these zeros to help us, they want us to go from least to greatest. What's the smallest here? 0.254. What's the next smallest? 600 or 780. That'd be 600. Then the next smallest after that would be 0.780. Now, when we're actually lining things up, we want to go back and use the original numbers. So we want to get rid of any invisible zeros that we were using. And that, well, somehow I managed to erase the decimals too. And there is how we line it up. Let's look at one more. Let's look at letter C. I have 2.3, 2.04, 20.1, and 2.195. Well, I automatically know that 20.1 is going to be the greatest. No question there. What's the next greatest? These all have 2. What's the next greatest number here? Ooh, look, 2.3. That one's done. What's the next greatest after that? Well, I have a 1 rather than a 0, so that's 2.195. And then 2.04. You can see I didn't use the extra zeros. You don't have to use them if you don't choose to. You do what makes sense for you and gets you to the right answer. So there is a way to compare negative numbers using their opposites. 1 compared to 3, 3 is bigger. That's pretty obvious. The 1 and the 3, 3 is definitely further down the line. So if we compare -1 to -3, -1 is actually bigger because remember, negative sign means opposite. So the opposite one's going to be bigger. So they want us to compare decimals, 1.3 or 1.35. 1.3, 1.35. Putting that invisible 0 in there, 1.35 is bigger, which means -1.3 is bigger because the sign flips if you change both of their signs. 13.5 to 1.35, well, that one's simple. I'd rather lose $1.35 than losing $13.50. Which one's bigger here? The ones is the same, the tenths is the same, 5 is bigger, but these are both negative numbers. So I want to eat the smaller loss. These both have 0.6. This would be 0.60, and this is 0.67. So I want to eat the smaller number because they're negative. -1.67, -2, that one's bigger. So to order the negative decimals, start by putting their positive numbers in order, then reverse the order to find the negatives. So let's take these 2.35, 2.335, 2.25, 2.5. Let's take the positive versions and put them in order from least to greatest. We're going to put least to greatest here. Which one's the biggest here? 2.5. Then the next greatest number, 3.353, would be 2.35. The next biggest number would be 2.335, and then the smallest number would be 2.25. When it's positive, this is least to greatest. If I add negative signs, that means now this list is greatest to least, so I would have to reverse it. They want you to order these decimals from least to greatest. Whoops, excuse me. So let's look at letter A and letter C. Go ahead and give those a shot. Letter A, -0.6, -0.48, -654. If I was doing these in a positive way, the positive least to greatest, the smallest one would be 0.48, the next smallest one would be 0.6, and then 0.654. And I can double check that. Because they're negatives, I'm going to put -0.654, -0.600, and -0.480. And you can see that all I did was switch the order. This was the least and this was the greatest. Now, least to greatest, because I'm losing more this way. And I'm running out of room, which is why I only did 2. So we have 5.2, 5.04, 50.4, and 5. Those are weird 4s. 0.85. So if I start off positive, the biggest one would be this one. The second biggest one would be 5.2. The third biggest one, 5.04, 5.08, would be right here, and the fourth biggest would be here. So if I want to go from least to greatest and they're negative, I'm just going to flip-flop the order. And this would make it the smallest would actually be the biggest. So if I go least to greatest, remember how 50.4 was the greatest? Now it's the least. 50.4, And then I would go number 2, negative 5.2, negative 5.085, negative 5.4. Remember that negative numbers are always smaller than positive numbers. So if we order these from least to greatest, the first thing we look at, which one are positive? These are positive. These are positive. So we know that these have to come first. So which one's bigger here? 0.6, 0.61. Let's add in that 0. That becomes 0.61, 0.60. Then we get into the negatives, and this is where it flip-flops. Negative 0.16, negative 0.616. Same thing over here. Do the positives first. 30.34 is bigger than 3.987. 30 is bigger than 3. When I flip-flop this, what would be the biggest number if these weren't positive between these two? 30.9 would be bigger if they were positive, so it goes at the bottom here. And then negative 30.45. And there we have these from greatest to least. So if I wanted to go from least to greatest, I would start at the bottom and work my way up. Ladies and gentlemen, I hope that you have an absolutely fantastic day.